Alrighty, here we go. And we're moving on to section 7, which is on solving equations. So take out your notes. And I will have you put this heading at the top, or if you have pre-printed notes, that's already up there for you. Section 7, solving equations. All right, we begin this, as we do all of our note sections, by focusing on and making sure we're deliberate about saying what our learning target is today. And so today we are going to say, I can solve one-step equations. We're going to be solving one-step equations today. And by the end, you'll see all the strategies. We're going to have a few vocabulary words here and tackle them head on. Are you ready? Here we go. And again, a reminder, pause the video at any time that you need to. So we've got 2 vocabulary terms that I want you to write down today, and we'll get some definitions up here. And again, these are your notes, so I do not make this a beautiful English sentence. Okay, these are your notes, and so I try to be not so wordy with them. Equation. An equation is some sort of math sentence. And it has to have the equal sign. That's what makes it an equation. That's what makes this different than an algebraic expression. An expression doesn't have the equal sign, okay? An equation does. So it could be something as simple as saying like 5 plus 2 equals 7. That's a statement, a mathematical sentence. You have 5 and 2. We're performing an operation, and we're saying that it is the same as or has the same value as 7. Today, what we're really going to focus on is something more algebraic. So we might have something like a minus 13 equals 7 or something like that. And we're going to work on the process to solve these. In order to do that, we need to talk about something called inverse operations. What inverse operations are is, and usually we have 2 of them that we take together as pairs, and we say they are 2 operations and that they undo each other. Okay? Undo each other. Oh, I can't even spell. Sorry. Each other. Make that an O. So, for example, adding and subtracting. Those undo each other. You add 5, you subtract 5. You end up back where you were. Multiply and divide. Those 2 are inverse operations of each other. Or I think when we get into about chapter 4 at some point, we might see raising something to the second power, or squaring something to square something, and then to take the square root of something. Those are inverse operations. So there's some examples, and basically they undo each other. Alrighty, well, what does this look like? Well, so first you're going to see some problems that are going to ask you to please tell me what value of x would solve this equation or would be a solution of the equation. Don't write those above words, but I want you to write this down. Here's your equation, x plus 8 equals 15. And then I'm going to ask you which one of these values, 5, 7, or 23, work as a solution that they solve this. So you would start by testing them. So I'd plug in a 5 first and say, oh, that's 13. So 5 doesn't work. Plug in 7. Say 7 plus 8. Hey, that one works. So 7 for sure is a solution. If you plug in 23, just double check it here. 23 plus 8, that would give me 31. That is not a solution. No. So our final answer here is just 7 is the solution of this equation. Look at one other one. X minus 4 is 13. Okay, and we're trying to figure out what number works there. Here are your possible choices, 9, 27, 17. So what you need to do is start plugging in these values where x is in the equation. So you test 9 minus 4. Is 9 minus 4 13? Nope. That's only 5. So 9 is not going to work. If it had said plus 4, that would have worked. But it's not. Try 27. So I try 27 minus 4. Is that equal to 13? You know, I could even put a little question mark and say, is that 13? No, that's 23. That's too big. So 27 does not work. Then finally, test 17. 17 minus 4, aha, that's the one that works. All right, so you'll see some problems like that where they give you some choices to determine if they're the solution. But now we've got to talk about how do we really go about solving them. Have you ever seen a balance scale like this? If things are perfectly level on each side, it's balanced. That's exactly what an equation is. It's like a scale. Each side has the same amount of weight and it's balanced. What our job is, we already did that. What our job is determine what the solution is. So I've got a 3-step process here when you're solving equations, and I want you to write down these 3 steps. First step, you've got to find that variable. Where is it? Because once you find it, then the second step is we have to work at getting that variable alone. It probably has some operations and other numbers with it, and so your job is to undo or use some inverse operations in order to accomplish that. We have some rules about how that's accomplished, and we'll look at them in a second. And finally, you should always check your answer. Make sure you didn't make a mistake with the sign because you were trying to be Speedy Sally, doing your work too quickly. Okay? The properties that you can use, or in other words, legal moves, you can add, you can subtract, you can multiply, you can divide. These are the main ones that we're going to see today. And FYI, there are a few other ones that you can do as well, and we'll add on to this list eventually when we get into some more complicated things. But the legal part of this is whatever you add, whatever you subtract, whatever you multiply, or whatever you divide, you must do to both sides of the equation. Okay? So I put that in big letters. And you must show your work on both sides of the equation. I don't want you to turn into some kind of sloppy jalopy that's only showing work on one side, because then technically you are not performing a legal move. I'll show you what I mean. So look at this one. All right. It says 10 plus n equals 18. First thing I'm going to do is say, okay, there's my variable. What I want to do is get this variable by itself. I tend to draw a line under the equal sign because that helps me determine where both sides of the equal sign are, or I should say both sides of the equation. And what you need to do is keep this balanced. So whatever I do on this side, I have to do on this side. Otherwise, it's going to go all kittywampus and it's not going to be a legal equation anymore. Now, right now, this is 10. It's a positive 10 that you're adding to n. And what I want to do is counteract that. We're going to counteract this by subtracting 10. But you have to subtract 10 on each side. See how I've written it on both sides? Because here's what happens. This 10 and this negative 10, they wipe out. They go to 0. They're opposites of each other. And now I just have n, because 0 plus n is just going to be n. That's exactly what I was hoping to accomplish. Remember, get the variable alone. What happens over here? It's no longer 18. It's just 8. Now I'm saying that's my answer. What you should do is come down here and check. Go back to the original. It doesn't have to be anything fancy. 10 plus, I said the answer was 8. Is that 18? Well, yes, sirree, Bob, it is. It worked. Let's look at another one. P minus 8 equals 9. All right, here's my variable.